My name is Weifeng Xu, and I'm Assistant Professor of Neuroscience in the Picower Institute for Learning and Memory. I got my bachelor's degrees in biophysics and physiology from Peking University. Then I came to the States, went to Brown University to obtain my PhD education with Dr. Diane Lipscomb in the neuroscience program there. There, I primarily study biophysical properties and pharmacological properties of a particular type of L-type calcium channel that is different from the well-known L-type calcium channel that has been identified in neurons. Later on, I went to Stanford University, did my postdoc research with Dr. Rob Malanka, primarily studying the scaffold protein's involvement in mediating and regulating synaptic plasticity in hippocampal CA1 neurons. In my own lab, I'm primarily interested in understanding how neurons respond to external stimuli, change its input and output strength to encode the information in the nervous system. As you may know, that for coding the information, there are two particular criteria that you have to consider. One is the specificity of the signal, and then two is the sensitivity of the system to catch the signal. So I'm set out to understand how, at cellular and molecular level, the specificity and the sensitivity of the neurons are being modulated and achieved. We think the neurons use a specific class of proteins to orchestrate and organize the signaling molecules in the synapse to achieve the signaling specificity. And we also think that activity-dependent translation and transcription of certain neuronal genes can change the sensitivity of the neuron in response to external stimuli, so that the plasticity outcome might be affected by what neuronal proteins are expressed at what kind of levels. Many of these molecular players that we're studying are intimately associated with neuropsychiatric and neurodevelopmental disorders, including schizophrenia, autism spectrum disorder, OCD, and also mental retardation and intellectual disabilities. To study how these molecular players are involved in synaptic plasticity and animal learning behavior will help us to identify pharmaceutical targets for intervention of these devastating diseases.